hints for homework 1, part 2. D.1, 3 homework questions from question number 14 through 16. The first question, which of the following growth functions has the lowest order of growth? Yeah. All right. So the last two relatively easy. So you can get it quickly, right? D, so you can, get the growth function level like this. n1/2, right? And a log of n. So something like this. Okay. C, you get, you just look at the highest term, right? After cancellation, you get n. Yeah. All right, so you can compare easily, right? But the hardest part is A and B. So how to get, which one growing faster in the long run. So here, although here I didn't say in the long run, but actually when you consider question like this, you should, think about in the long run. All right? Yeah. Then, because that's the essence of the asymptotic notation. Asymptotic notation, we only consider the cases in the long run where n is very large. Okay, we consider that. All right. Then another thing is when you look at the exponent of power of n, power function, power of n, the exponent is very small, 0. How many zeros after the decimal point? 5 zeros. But there is another position after 5 zeros. So that is 1/1,000,000th, very small. So then, based on my experience, many students feel this number is very, very small, so small, right? Yeah. So they answer this question still by their intuition. All right. And some students even try using calculators to do some experiments. So I saw those students before. Try to plug in some numbers and using calculator. That's not good. So here, my suggestion, do not use calculators. Okay? Yeah, do not use calculators. Yeah. The reason is very simple. When you plug in numbers in some calculator, you cannot plug in extremely large numbers, right? Because it's not realistic, right? Huge number. Can you try huge number? Your calculator will get overflow, right? Yeah, because your calculator may have that overflow problem. But when we consider our algorithm problems, we don't have that overflow limitation, right? Yeah. So for that reason, yeah, don't even try it. Okay. All right. So for the comparison, here, let me give you the main consideration. You should consider this power function as n to the dth power with d positive. Can you compare these two functions? Log function and the power function. We did that. In Module 2, we did that problem. In Module 2, I give you many examples. So one of the examples, exactly this one. And I use the L'Hopital's rule. So remember L'Hopital's rule to solve it. Okay? So you should use that result to answer this question. Then you will be fine. Okay? Do not use your intuition. Because your intuition, many times, it is not reliable. Here, this is a typical example for that case. All right, yeah. So with this information given here, yeah, I think you should be able to answer the question. All right, yeah. Next question. Number 15. So this one is another similar example to the previous one. Yeah. But here, the first one is a power function, yeah, because variable is at the base. The second one is an exponential function. So we compare a power function with an exponential function. Okay? All right. Here, another situation, you may, many of you may like to use your intuition. All right? Yeah. Because here also 0.000, many zeros. I can put a few more zeros there. Okay? Yeah, but it is not that important. Yeah. But here, then, the similar problem as the previous one, if any of you try to use calculators to plug in some n numbers, you will get the same problem. Okay? Yeah. Do not do experiments on this one. Do not do experiments. Okay? The reason is still overflow problem, right? Because only when n is very large, because here I give you this in the long run, right? So from the wording, you can see I give you some hint, some clue, remind you, you should consider when n is very large. But when n is very large, you will get overflow quickly, right? Yeah. Think about this function. How large number you can handle, right? How large the number you can handle. Think about this. Okay, when n is very large. All right, yeah. Then we can only answer this question mathematically. All right? So here basically we compare two functions. The first function is the power function, n to the d, still with d positive. Any positive number, just a positive number. Here I give you n, d, how many zero? 1 million, right? Here, d equals 1 million. Yeah. The second function is exponential function with a greater than 1. Strictly greater than 1. Yeah? All right. Yes. Then, in order to compare, which one grows faster, still use the limit. When n goes to infinity, the power function over the exponential function. I give you this example still in our Module 2. Module 2, near the end, I give you many examples. You can find it there. Yeah. So there is one like this. And we use the L'Hopital's rule. L'Hopital's rule. Okay? Yeah. Here I do not go to the detail of L'Hopital's rule, right? Yeah. So the story related to the L'Hopital's rule. There's a lot of content related to the L'Hopital's rule. Yeah. So I do not go through that part. So you can look at the notes or the videos if you need that information. Okay? All right. If you know the answer of this limit, then you can find the right answer easily for this question. Okay? Yeah, that's number 15. The last one for this video, D.1. Yeah. All right. Yeah. Here I give you the video reference. Yeah. So let me just. This is the video reference. Okay. Yeah. Notes reference or video reference, so you can find that easily. Yeah. Oh, yeah. Actually, this one is exercise question. So that is a similar one to this one. But module 2, when we do this limit, we did it in our notes. In our notes, we directly work on this limit. Yeah. You can even find the answer in our notes. Yeah. All right. Yeah. Number 16. Yeah. This one, actually we did a similar one in an example. Yeah. I remember we did a similar. Yeah. I give you a little more complicated question. Yeah. In this question, you can see n is given very large, 100 to the 10 to the 10th. Okay? Yeah. So it's a very large number. Then log base 10, another level log base 10 of n. Right? Yeah. So although here, because you can do step by step, okay? So it should not be that complicated. So for the first expression, thus, right? So I think it should not be too complicated for you, all right? And because we know 100, we can write it in 10 square, right? Yeah, 10 square, because if we use the base 10, so we can easily get an answer for log base 10, right? Yes. So then we can write this as 10. How about that? Okay, yeah. So you can treat this as one number. Okay, all right. Then this one, yeah. So for this one, I hope you're not scared by this format because we have so many level of exponents. Yeah. 10 to the 10th parenthesis, there another, exponent as a power of 10, but this is a negative power. Okay, yeah, all right. But actually, if you look at it in this way, this is basically n to the nth, then we raise power of b, a, b, two numbers, right? If we use variables to represent those power number, exponent numbers, then we have that. So that's basically based on the power function property. Is it an A times B? Product of two exponents. Product. So that will be much easier, right? So you can simplify it. Okay. So then you compare with the first expression. How about that? Okay, how about that? Yeah. So if you work on your scratch paper carefully, so step by step carefully, using the, properties of logarithm function and also the power function, okay? Exponential properties, okay? Yeah. Then you can figure out, so which one larger, which one smaller, okay? All right, so that is our D.1 video.